On Mars, it's dawn on any given day in 2021, and a thick reddish haze surrounds the Perseverance rover, newly awakened by the sunrise. Like a big boar rasping in the ground, the clumsy robotic geologist pokes his head through the jagged rocks as dust devils begin to stir on the horizon, and the walls of the Jezero Crater seem to invite him on a long gallop across the plain of Isidis Planitia. But Perseverance is not alone this time. Unlike the robots that in past decades have preceded him across the sands of Mars and then slowly died out in complete solitude, this time the rover has someone or something to keep him company. A few meters higher, in fact, there is a small drone that monitors the moves, just like one of those birds that live in symbiosis with the buffalo of the African Serengeti. In the meantime, the sun comes out of the fog, while the two proceed in silence, exchanging every now and then a few glances in a glitter of crossed cameras. On Mars, another day of work has begun. What we have just described could be one of the many moments of that daily routine that will soon concern the stay on Mars of a couple of robots, very different from each other, both in tasks and in size. The Mars 2020 mission is in fact about to release on the red planet the rover Perseverance, and it will do so on February 18th at about 2100 Greenwich Mean Time, after a journey that lasted 6.5 months. We can undoubtedly say that never before man has sent on Mars a medium so important from the point of view of innovation. Among its peculiarities, there are real technological bets that, despite being considered high risk by the same agency, will provide important data even if they fail. Among the many noteworthy innovations, our attention has been captured by the Ingenuity, the first instrument intended to fly in the atmosphere of another planet. Even though in 1985, two balloons released by Soviet missions, Vega 1 and Vega 2, had crossed the skies of Venus collecting meteorological data, Ingenuity will undoubtedly be the first controlled power flight ever attempted on another world. The Martian helicopter is defined as a technological demonstration highly risky and innovative at the same time, thanks to which it will try for the first time to test a new approach to the exploration of Mars. No additional technological instrumentation and no scientific objective. The interest is entirely engineering and is intended to demonstrate that even in the thin Martian atmosphere, it is possible to fly. Its development began 8 years ago at the Autonomous Systems Division of the Jet Propulsion Laboratory, with the prospect of realizing something daring. Since the Martian atmosphere and gravity conditions make it actually difficult to fly a helicopter drone of this kind. Difficult, yes, but not impossible. And it is precisely from this assumption that was born the confidence towards the project, bringing it to full realization. Although it may not seem so, the design of this small aircraft has involved the most diverse areas of aerospace engineering. It has not been easy at all. In fact, to integrate in such a light device the numerous devices and sensors able to obviate the problems such as low atmospheric density, intense cold, weak gravity, and the impossibility of an assisted guide. To do this, the NASA team used the space simulator of JPL, a vacuum chamber about 8 meters wide from which the Earth's atmosphere was replaced with carbon dioxide, the main ingredient of the Martian atmosphere. Then a mechanical gravitational exhaust system was developed designed to simulate gravity on Mars, and then several test flights were completed. The real test, however, will be in the field, and NASA is ready for any eventuality. More than a helicopter, Ingenuity resembles a drone. It is in fact a very small device, weighing only 1.8 kilograms. The structure with the electronics and batteries is enclosed in a cube-shaped fuselage of about 14 centimeters squared, mounted on 4 legs each 38 centimeters long. Ingenuity will be able to fly thanks to 2 pairs of counter-rotating blades of 120 centimeters in diameter that will turn 40 times per second, or 10 times faster than those used in helicopters on Earth. Despite the very low weight, in fact, that on Mars will also be reduced to 1/3 due to the lower force of gravity. The problem for the rotors will be able to take hold in an atmosphere that has a density that is just 1% that of the Earth. Getting up in the air on the red planet is equivalent to doing it from an altitude of 30 kilometers on Earth. No existing helicopter has ever gone that high. It is more than twice the altitude at which jets normally fly. The helicopter is designed to provide overhead imagery with about 10 times the resolution of orbital imagery. It carries tiny avionics and communications equipment, a navigation camera, a single solar panel, and rechargeable lithium-ion batteries, as well as heaters to keep the electronics warm during the frigid Martian nights. To hinder the proper functioning of the drone, there will be in fact also the very cold temperatures of the Jezero Crater, where at night it will drop even to minus 90 degrees Celsius. These temperatures could put a strain on components and electronics, although tests on Earth indicate that everything should work as expected. The drone will recharge its batteries thanks to an integrated solar panel, and the energy will serve, as well as for short flights, also to keep the vehicle warm during the freezing Martian nights. To do this, a real thermostat has been installed to monitor its state. There are no scientific instruments on board, only the camera facing down for navigation, landing and scientific terrain survey, and a communication system to transmit data to the Perseverance rover. Mars's non-existent magnetic field precludes the use of a compass for navigation, so a tracker tied to the sun's position is planned. Additional devices include gyroscopes, tilt sensors, an altimeter, and hazard detectors. The biggest problem of all, however, is control. We know how the distance separating us from Mars makes communication difficult and does not allow real-time controls. The radio signal will take about 22 minutes to make the round trip in the period in which the drone will try to get up in the air, a weight that always makes it necessary to act with extreme slowness and caution in driving the rovers on the surface, let alone a helicopter in flight. So it won't be possible to steer the drone with a simple controller, as is usually the case with similar vehicles on Earth. Ingenuity will move according to the parameters set by its engineers on Earth and will fly completely autonomously. During flight, Ingenuity will analyze sensor data and terrain imagery to ensure that it remains on its intended flight path. Since we're talking about an experimental aircraft and the Martian environment will be decidedly hostile, there will be several objectives to be achieved in succession before proceeding with the actual initial flight sequences. NASA remembers that first of all, Ingenuity will have to arrive intact. And here we must obviously cross our fingers. Everything will depend on the usual 7 minutes of terror at the end, when the probe will have to slow its descent, get caught by the gravitational field of Mars, and then cross the thin but insidious Martian atmosphere. After touchdown, it will be necessary to wait for the helicopter, which is positioned underneath the rover, to be placed without damage on the surface, and for the various parts to stretch correctly, with movements guided and controlled by a series of springs, until it assumes its flight configuration. It will then be necessary to wait for the panel to charge the batteries in the weak Martian sun, and also check that all systems are surviving the cold. After undocking the helicopter, Perseverance will move at least 100 meters far enough away to avoid being hit in the event of a faulty takeoff, but still close enough not to disrupt radio communications. The most important test flight will be the first, replicating those previously conducted on Earth inside the vacuum chamber. The drone will take off, hover for a few tens of seconds, venture a short horizontal flight, and then turn around and land in its pad. Once Ingenuity proves it can fly autonomously and succeeds in making the first return, then it will proceed with increasingly complex tests at greater distances. It is expected that the drone will be able to stray up to a maximum of 300 meters from Perseverance, flying at a maximum altitude of 30 meters with maximum horizontal speeds of 10 meters per second and vertical speeds of 3 meters per second. The most important limitation will be the flight time, which cannot exceed 90 seconds, which is all the time available before the batteries are discharged. Each flight will consume about 350 watts of power, and Ingenuity's solar-powered batteries will take an entire day to recharge between flights. The color camera will capture images of the surface explored during the flight sessions. These will then be sent back to Earth, so if all goes according to plan, we will soon be able to see breathtaking Martian panoramas unprecedented in history. Once demonstrated that Ingenuity is able to fly on Mars, NASA will proceed with the development of new similar technologies to be sent to the Red Planet, In fact, there are several projects in development that do not only concern Mars, but also other planets such as Venus or the many moons of the solar system, such as those of the gas giants, for example. A more powerful and heavier craft than Ingenuity could, for example, transport scientific instruments or other things to places that rovers cannot reach, such as certain ice slopes exposed on the sides of ice caps or inside the walls of steep craters. It could also report hazards and obstacles to rovers in motion, or guide and monitor a group of astronauts exploring. All this with much more detailed images than those normally made by probes in Martian orbit. Future scenarios even involve swarms of helicopters flying together and working cooperatively. And in this regard, JPL is studying 15-kilogram heavy Martian helicopters, capable of carrying up to 2 kilograms of payload. But NASA is also funding a much more ambitious mission based on a super helicopter called Dragonfly, intended to be launched in 2027 to Titan, Saturn's largest moon. Aerial flight on Titan is aerodynamically more favorable even than on Earth, as gravity is lower, winds are weak, and its very dense atmosphere allows for efficient rotor propulsion. All this will allow Dragonfly the possibility to explore on long distances and at altitudes up to 4 kilometers the complex geology of one of the moons considered more suitable to host some form of life.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.